Hey everyone, sorry again that I am not here today. We are going to finish up lesson 2.1, so we're looking at 2.1c. We're looking at 2.1c, and we haven't had a lot of work time this week, and I understand that. We've had rules and regulations and intro stuff we've had to go over, and yesterday you didn't have a lot of work time. The lesson and the warm-up took a lot of time. So instead of having you do the warm-up today, I'm just going to talk through it a little bit. And then after I talk through it, I'll show a couple examples from the lesson, and you'll have lots of time, hopefully, to work today. So this warm-up is similar to yesterday in that we're taking the parent function and we are comparing it to two other functions. Now, so far, when we have looked at these quadratics, which remember this is in vertex form, meaning we can get our vertex from this HK, X always lies, Y tells the truth. So we can get it from in here and out there. When we've been looking at vertex form, we've seen movements in here, which move us left and right. We've seen movements here, which move us up and down. We have also seen movements here with our vertical stretch and vertical shrink. Lastly, we have seen movements here and here. When we have a negative, we get a reflection in the X and a reflection in the Y. So we really have 2, 4, 6, 8 movements with our graph so far. Now today we're going to look at the last two types of movements. Now notice in these examples here, specifically g of x and h of x, there is a number right in front of x, and we have not seen that yet. We've only seen a negative sign right in front of x in our parentheses like that. We have not seen a number. So we're going to look at what does that number do? How does that change things? Well, we know, before we look at these examples, one last thing. We know that when we had something like this, we would expect, with x always lies, typically that means we're moving this way 3 units. But remember, we talked about when we have something in front of x, that changes our rule of x always lies. So we really would be moving over here. X is actually kind of telling the truth here. So we know that something in front of x makes things kind of goofy and makes our rules go out the window just a little bit. We can still see patterns, but it's different than our baseline rule of x always lies, y tells the truth. So let's see what happens here. We've got our parent function right here. We have g of x right here. And then we have h of x over here. So already we see some things are narrower, wider, moved left, right, all that kind of stuff. If we were to answer these questions, how are they different from each other? We would notice that g of x grows faster than f of x, which that we should kind of expect. I mean, g of x has a 2 in front of it. We know that numbers greater than 1 make us grow faster, so that actually makes sense. We see that h of x is wider and grows slowly, which again, it has a number between 0 and 1. It has a decimal. That should check out to us, that it makes it grow slower. So far we're doing pretty good. Looking at question 2, how are these different? Well, this is different because the number is right in front of the x. We haven't seen that yet. But also, if you look really closely, this should, based on what we know or have talked about, this should have a vertex right here, but it doesn't. This should have a vertex also right here, but it doesn't. So this is not, that's where our number in front of the x changes things and makes things a little tricky, is it does not, if we have a number in front, does not follow our normal left-right rules. Just like a negative makes it so we don't follow our normal left-right rules, a number would make it so we do not follow our normal left-right rules. Now, there is a pattern to these things, but instead of trying to teach you the pattern for how this affects that and how this affects that, we're going to rely on our graph and our calculator to help us see those movements. And this is where especially changing our window and things like that may be important and may be helpful. We notice that these are still stretching and shrinking, but our conclusion should be that these stretches and shrinks and these movements are a little bit different than what we've seen before. With that said, our goal is going to be two things, just like yesterday. We need to be able to see an equation, and we need to be able to describe it and graph it. We need to be able to see a description and be able to write the equation for the description. You've seen this graphic before. We've talked about reflections. We've talked about these stretches and shrinks. This was covered up the first time that you saw it. This is just the function notation when we're talking about horizontal stretches and shrinks. Notice our parent function is here. When that a value, that number that's right in front of x squared, or right in front of x, inside the parenthesis, when it is a fraction, we're going to stretch, or excuse me, when it's a fraction, it's going to bring us away from the parent. We're going to make it be wider. When it is a whole number, it's going to come closer to the axis. It's going to grow faster. Now, this is where we need to be extremely careful. Let's say that we have, let's take the pink. Let's ignore the orange. Remember that we are talking about horizontal, so this is our horizontal stretches and shrinks. If we look at going from the yellow to the pink, if we're talking about horizontally, this is more taking our horizon and stretching it out. So if we look at this equation, we would expect to see that it's wider, but usually if we see a fraction, we say that that is a shrink. But, and listen very carefully, when it comes to a horizontal movement, something right in front of the x, it still stretches us out, or excuse me, when it comes to, wow, I just messed up like the punchline there. When it comes to a horizontal movement and we have a fraction in front of the x, it still is making us wider, but it is taking the horizon and stretching it out. So we would classify this as a horizontal stretch. Now, when we talk about the factor, we would say that this is a horizontal stretch of, and we would take the reciprocal of 4. Which I know is backwards from everything we talked about yesterday. Let's look at that a little bit more. When we look at this equation, like we talked about, we're going to graph it first, then we're going to describe. So we see a fraction in front of x. We know that that is a horizontal movement. Let's not worry about the stretch or shrink part that I just talked about quite yet. Let's graph it first. So if I'm you, I would plug this into my calculator right away. So if you want to follow along with me, take a second, plug this into your calculator. As you're plugging it in, we know that anything in front of x will affect our left and right movement. So by now we should have it plugged in. and you will see that we will have moved 6 units. 1, 2, 1, 2, 3, 4, 5, 6. We've moved 6 units to the left. Now, since it's a fraction in front of x, we're dealing with a fraction there, we know that that makes us wider. So let's say the parent, or let's say normal width was here. We know that that 1/2 made us wider. So again, going back to describing it, we moved left 6. But if we're talking about, we know this is a horizontal movement. We cannot describe this as a vertical movement because this is right next to the x. It's not outside of the parenthesis. So when we're talking about a horizontal movement, this took us horizontally and it stretched us out. So we would say this is a horizontal stretch. And when we describe any type of stretch, we don't use fractions to do that. So instead of saying 1/2, we take the reciprocal. It would be a horizontal stretch with a factor of 2, or by a factor of 2. Why don't you take just a minute, pause the video, and try letter B. All right, hopefully you have tried letter B by now. So, first, we're plugging this into our calculator. We know that this is going to have a reflection in the x. We know that our left and right movements are going to be a little bit messed up because of that 4 in front of the x. So when we look at our calculator, we should see that we only moved right 1/2. And that could be kind of tricky to find if you're not really good at using your table. So we had a horizontal movement by 1/2. That 4, it's a whole number in front of the x. We know that makes us grow faster. Now, let's say that our normal width was here, and you didn't have to write this in, but let's just say our normal width was here. First, we know we have a reflection in the x. We flipped over that x-axis. We know we are right 1/2 unit, or 0.5 units. Now, we know we have a horizontal and if we go from our parent to what we did, really with the horizon horizontally from our parent, we took it and we shrunk it. We squeezed it in, and then that made it grow faster. So we have a horizontal shrink by a factor of 1/4. So remember, shrink, whether it's vertical or horizontal, will always have a fraction accompanied with it, or a decimal. When that shows up in our equation, though, it's going to be a whole number, so we need to take the reciprocal of what is in our equation. Let's talk through letter A. We're not going to graph it just because I know that you guys are capable of punching this stuff in your calculator. If you look at letter A, you know that it has a reflection in the y. We know that it's going to have this would be a horizontal stretch by a factor of 3, because again, we take this reciprocal. Now we know we'd have some type of left-right movement, but this negative 1/3 messes with it so much that we would need to graph it to see what that would be. So if you were to graph it, you'd see that it moves 18 to the right. But again, that negative 1/3 messes with it. Now out here, we would be down 2. So you don't have to write this one down. We're just talking through it a second. Hopefully, by talking through it, we're getting better at recognizing how those horizontal stretches and shrinks work. Now, I want to talk about letter B, because if you think back to yesterday, where did it go? We had a problem very similar to it right here. And we said in order to write it as a vertical movement, we had to distribute that square. We had to distribute. You could totally do that. If you did that, it'd be a vertical stretch 16. Remember, vertical, we really like. Vertical's easy. We don't reciprocate, nothing like that. But if you did not distribute, this 4 is directly in front of the x. So this 4 could also be considered a horizontal shrink by 1/4. Get this, here's why it works, then we'll look at our last example. Some of you are like, Mr. Lehman, I'm cashed out by now. If that is our parent, we know that this, and we're allowed to distribute, that's no big deal. We know that this is growing really quickly. We're taking, when we talk about a vertical movement, we're taking our parabola, our parent, and vertically, we are grabbing it and stretching it out. Now, when we talk about a horizontal movement, this still would look like this. Horizontally, we are taking our parent and we are shrinking it. We're trying to smush it towards the middle. So this is not going to be a huge test point, quiz point, anything like that. But I just want you to be aware that some things, this in particularly, you could see written as and understand it as a vertical movement, which I would recommend because I do think that's a little easier. Or you could talk about it as a horizontal movement. Last piece of this, we need to be able to read something and write an equation for it. So they start us out with the parent function. Now they say let the graph of G be first a horizontal shrink by a factor of 3. So here, they tell us our factor is 3. We apply that, or 1/3. We apply that factor of 1/3 by putting in a 3. So horizontal shrinks and stretches, we need to make sure we're using that reciprocal. Now, if I were doing this, to simplify things, I would distribute that before I move on to the next step. Next, we have a reflection in the y. Now, in this case, that reflection in the y does not change anything. So we can simplify. Because if we were to square, or whatever comes out of here is going to be positive no matter what. Lastly, we're going 2 units up, so we need to add 2. Now, big picture, I could totally understand looking at this and be like, holy smokes, this is over my head. I get it, it's difficult. This horizontal, throwing this horizontal stuff in with the rest of it is not easy. But rely heavily on your calculator. If you are not confident in those patterns, if you haven't picked up on those yet, use your calculator and let that help guide you when you're graphing. Let that help guide you when you're trying to make your descriptions. Secondly, looking at the 2.1c homework. On that page, it's primarily horizontal movements, but I did mix in a couple of vertical movements on that practice page as well. So don't lose sight of everything we've been talking about. I mean, there's a couple of them where they are vertical movements. Remember, vertical movements, stretches and shrinks, are outside the parentheses. Horizontal are inside. No matter whether it's vertical or horizontal, if it's a whole number, we still consider that a stretch. If it's vertical, we say it's a stretch with by a factor of 2. If it's horizontal, it's still a horizontal stretch, but we just say the factor is 1/2. It's the reciprocal. Same thing is true as if we're talking about shrinks. A shrink is still something between 0 and 1. I don't want to use A. The numbers between 0 and 1. If it's vertical, let's say that it is 2/3. If it's a vertical, meaning it's out front, we'd say it has a factor of 2/3. If it is horizontal, meaning it is right in front of the x, we have to take the reciprocal to talk about the factor. It's a factor of 3/2. Do the best you can on that homework sheet. The key for both yesterday's and today's homeworks are posted. So if you're looking at your job today, and this is all on Canvas, but first it was the video, and you just completed that, the long video. Then it was correct homework. So that would be your 2.1b and 2.1c. Like I said, if you have questions, take a picture of the question and email it to me, and I will absolutely help you out. I'll also take just a couple of minutes in the beginning of class on Friday to answer questions, and then we will move on to the next lesson. I would like you to, before you walk into class, to take the 2.1c exit ticket. So thank you guys for hanging in there. I trust that you'll do the best that you can to work through these problems, and I already know that you'll behave well and that won't be an issue. So we will see you on Friday.